You can see the network diagram on screen. Well, on the left hand side, we have the Linux server. On the right hand side, we have the FortiGate. And behind the FortiGate firewall, we have the web server running at 14.140.40.109. And the FortiGate firewall port 1 is the remote peer IP for the IPsec VPN. And the internal network, which is port 2, 14.140.40.108, connects to the web server. On the local end, we have the Linux server running Ubuntu. And ETH0 is the peer IP here with the IP address with an IP address 192.168.0.2. And the internal network is 10.10.10.2/24 on ETH1, which connects to the host. And the traffic will be initiated from the internal host 10.10.10.3/24. The traffic will then get into the IPsec and then will be encrypted. On the other end, it will be decrypted and send it to the web server. The reply again goes into the IPsec tunnel, encrypted, and then here on the Linux server, it will be decrypted and send it back to the source. So pretty simple network diagram. In this particular session, we'll see how to configure site-to-site IPsec VPN using IKE version 1. So let's get started. So this is the Ubuntu machine. And you can see the operating system, Ubuntu 20.04 LTS. And this is the kernel information. You can see the IP address on ETH0, 192.168.0.2 as per the diagram. And on ETH1, we have 10.10.10.2. And on FortiGate firewall, we already have the IPsec VPN configured site-to-site using main mode. And these are the proposals and the parameter set for phase 1 and phase 2. And we'll have to match this on Linux server. And I have the documentation ready for this tutorial. You can access the same. I'll leave the link in the description. So this is the documentation. Let's get started. So first thing is to update and install the required packages. Let's try to update everything before we start the Strongswan VPN package, which then will be used for the configuration of IPsec. Okay, seems like it is already updated. Now let's try to move on to the package installation step. apt install Strongswan. Let's try to install the package. Package is installed. Let's try to check the version of Strongswan installed. So you can see here. Let's try to check the status of the service. Okay, it is inactive. We will start the service. After the configuration, before initiating any configuration, we'll have to set certain kernel parameters. For example, IP forward. Most of the time, this will already be there on your kernel file configuration. If it is missing, then you'll have to add it. Make sure you don't leave any space in between equal to and the value. And you can check the parameter using this particular command, which will give you all the kernel parameters currently configured. So you can refer to this particular value and set the recommended value that I've shown in the article. So now I will move on to the IPsec configuration. So you have two files. Once you have installed the Strongswan package, you will have two files available. So this is the configuration file, and this is the ipsec.secret, where you will define the pre-shared key. So let's try to start with ipsec.secret, where we will define the peer IPs and the ipsec.secret. So you will have to copy the content like this. I'm not changing the pre-shared key. This is already configured on FortiGate firewall. You can see this. This is encoded, but is the same key that we have used here. Let's try to copy paste this. Okay, so this is the source IP, peer IP 192.168.0.2, and this is the destination 192.168.0.108 pre-shared key. And if you have multiple IPsec, then you can enter the parameter in the next line so that you can have multiple entries there. So now we'll have to configure the IPsec phase 1 and phase 2 as per the configuration that we have done on the FortiGate firewall. So we are going to use the same parameter for phase 1 and phase 2. Both the phase 1 and phase 2 proposal should match here, along with the traffic selector, which is the proxy ID. Interesting traffic. Let's try to configure the IPsec phase 1 and phase 2. Okay, so for that, you will have to copy paste the content. I'll explain the content here in some time. Just give me a minute. Okay, so this is pretty much the global configuration. So this is the name of the IPsec tunnel, Linux to FortiGate, or by secret, and left-hand side means this one, local end Linux server, where left ID is this 192.168.0.2, and left subnet is this 10.10.10.0/24. Similarly, the right side is going to be your remote end, which is the FortiGate firewall, write IP or IDE is 192.168.0.108 and write subnet is 14.140.40/24. So that is what we are going to configure here. So you can see here, left ID 192.168.0.2, left subnet 10.10.10.0/24. You can refer to the diagram once again. And right is 192.168.0.108, 14.140.40/24. So that's pretty much about the traffic selector and the peer IPs. Next comes the proposal. And you can see here the proposal, phase 1, AES 256 SHA-2, group 2, MOB P1024 means group 2. You can compare this on the FortiGate firewall. This is the phase 1 proposal. So here I have multiple algorithm configured, but here on the Linux, I have specifically mentioned AES 256 SHA-2 group 2. And you can see here AES 256 SHA-2 and group 2. Coming down to the phase 2 proposal, you can see here ESP, AES 256 SHA-2. You can see here PFS is disabled. AES 256 SHA-2. Phase 1 lifetime is 1 hour, 3600 here in seconds. And phase 2 lifetime is 28800, which is 8 hours. This is in hours. This is in seconds. This is the DPD configuration. I have set it to on demand on FortiGate firewall so that I don't have to worry about explicitly enabling or disabling it. So DPD delay 30 second, DPD timeout 120 second, pretty much the default values. DPD action restart, auto start. So we have the file configured with phase 1, phase 2, along with the IPsec secret with peer IPs. Okay, so now we have the appreciate key and the phase 1 and phase 2 configuration. Let's try to start the IPsec engine and let's try to check the status. So to start the IPsec VPN, you will have to use IPsec start or restart to restart the IPsec. So you can see here it is already running. Now let's try to check the tunnel status using IPsec status. And you can see here it is in the established state. You can check the status explicitly for a tunnel by giving the command ipsec status and this name of the tunnel. And there's one more thing, which is the IP table or the firewall settings. In my case, I already have the rule to accept the traffic. So you can see here, this is the rule to accept the traffic from outside, which is the remote peer IP, local peer IP. And this is the firewall. This is the rule for the outgoing traffic, which is going to be the traffic from 10.10.10 to until 10.14.140.41.08. So in my example, I have not configured the host explicitly on different machines. So instead, what I'm going to do here is I'm going to take the ETH1 IP as the source, which is 10.10.10.2/24, and I'm going to reach out to port 2 IP address, which is 14.140.41.08 for this setup. But in your case, you might have to explicitly configure the host and the web server. For simplicity, I'm skipping that part. So you might have to allow this traffic if there is any sort of blocking, and if you need to have the NAT, then you will have to set the rule inside the NAT table. So I do not have it right now. So if you want the NATing to take place, then you can define the rules here. But in my scenario, I have the simplest routing. So I do not need NATing in my scenario. So I'm not enabling anything. Okay, so to bring up the tunnel, you can use IPsec up. To bring down the tunnel, let's try to bring down the tunnel. So you can bring down the tunnel using IPsec down this command. Now it shows closed. Now you can bring up the tunnel with the command IPsec up. Hence, it is bringing up the tunnel established state. And you can enable the Strongswan services during the boot automatically by using this command systemctl enable Strongswan starter, so that it starts automatically when the system is rebooted. Now to know about the SA IPsec essays, you can execute the command ipxfrm state, which will give you the information about the security association associated with this particular tunnel that we have configured. And you have various information here: SPI value, authentication HMAC, encryption key. This is the incoming SPI. This is the outgoing SPI. And you can compare this on the other end. So you can see here SPI value. This will be in reverse fashion. So you can see here 6ACT404A. And the incoming SPI here, which is going to be the outgoing SPI value there on the FortiGate. You can see here. So you can use this command to get the information about the SA. Now coming to the next part. Well, to capture the ESP packet, you can use the filter. And this is the interface on which the IP address peer IP is configured 192.168.0.108. If you enter this, and if you try to initiate some traffic from the FortiGate firewall, you should be able to see some traffic there. And this will be the ESP packet, the encrypted packet, not the actual packet. And you can see here, this is the encrypted packet, encrypted ESP packet, and you can see the SPI value, incoming SPI. And you can match it up with the existing SA information here. 94. So this is the incoming SPI value on the Linux machine from 108 towards .2. So this is the incoming SPI value. And to capture the actual packet, well, you can change the hostname to actual IP address of the server 14.140.40.108, protocol 1 on the same interface, ETH0. And you can initiate some traffic again. And you can see we are receiving the actual traffic, which is not encrypted. This is the decrypted traffic on the Linux machine. And to know about the algorithm available, for example, like I showed you, so you might be wondering how can I know more about the available algorithm? Well, to know about that, you can use the command ipsec. I guess it is list ALGs. Okay. So this particular command, ipsec list ALGs, will actually give you the information about the available encryption, integrity, hasher, or TH group information available to configure on your IPsec config for phase 1 and phase 2. So if you closely see, I have used AES, CBC, and I have used SHA-256, I guess. SHA-2. And I have used mod P 1024, which is group 2. And you can get the information about that here, which is group 2. So you can refer to this particular available algorithm to configure phase 1 and phase 2 proposal. Let us try to initiate some traffic from the Ubuntu machine as well. And you can see I'm able to ping the remote ends. You can see here the request and the reply from the Linux machine. So that proves that everything is working fine as per our configuration. In the next video, I'll cover more details about the configuration alongside FortiGate from scratch, so that it'll be easy for you to understand the entire configuration on both the machines, on the Linux machine as well as on the FortiGate. That's all in this video. Please do not forget to subscribe to the channel, hit the like button, and see you in the next video. Bye.